The final test is going to be testing for surface area. So we're going to go from marble powder, which has the largest surface area, all the way up to large chips, which has the least surface area. We're going to do exactly the same experiment as before. So what we did for concentration and temperature, and we're going to have a look at how much carbon dioxide is produced in 30 seconds. For this experiment, we need to keep the temperature and the concentration the same, so we're going to use room temperature 0.8 molar hydrochloric acid. First one then, small surface area, large marble chips. Next one, which is the medium-sized chips. The next one are small marble chips, so we've got a medium-sized surface area now, quite large. And finally, the larger surface area, the powder. So as you can see, as the surface area has got larger, the volume of carbon dioxide produced in 30 seconds has also increased. So if you increase the surface area, you increase the amount of gas, you increase the rate of reaction.
So in this example, we're looking at surface area. So we're going to have a bar chart because I haven't got the exact volume. So, to draw our bar chart, first of all we have a look for the very small surface area, which produced 11 mil. We then have a look at our small one, which produced 19 mil. We then have a look at our medium, which produced 44 mil. And then large, which produced 83. We draw our bar chart. Which shows us that as the surface area increases, so does the volume of carbon dioxide produced in 30 seconds. When we talk about surface area, we talk about the area that the particles can attack. So the larger the chip, the smaller the surface area. So if we have a look at this, our marble chip, there are only 4 areas that the particles can react with. These edges here. To increase the surface area, you can break the marble chip into 2, which gives you 2 extra sides to attack. You could break it into 4, which now gives you even more area to attack. Or, as we did in the practical, break it up, crush it into smaller particles. The smaller the particles are, the larger the surface area, the more areas that the acid can attack with, therefore more successful collisions per second. So if we have a look at this simulation here, we've got a low surface area. So when I start the simulation, there's only 4 areas along here, here, here and here that the acid particles can reach and attack. Therefore it takes longer for successful collisions to occur. So if we go with 10 products again, this time it has taken 8 seconds exactly to produce 10 of our products. If I increase the surface area to medium, meaning I've now got these areas to attack here, and start the simulation, you will see we've got more areas to attack, therefore there are more collisions per second, therefore the time taken to produce 10 of our product should be less. And as you can see here, 4.58 seconds, which is less than the 8 it was previously. And finally, if we have a look at the high surface area, so we've broken it down into smaller chunks again, we start the simulation, the more area to attack once more, and therefore the quicker it will produce 10 of our products, which in this case was 3.28 seconds.